It certainly seems that many of the things that I've been talking about in past episodes haven't exactly gotten any better recently. You only have to watch the news once and 10 minutes later you'll be up to date on all the senseless destruction that is going on in the world. But while I do admit that it's better to be informed than ignorant about the world at large, we also have to try to focus on the things we can change and the good we can do as individuals in our lives. And be it just to keep our own sanity. And while it might sound rather insane to some, what does that for me is fixing things. So let's see what we can find on the scrap today. See those steel sheets leaned against the wall? We will take those with us. Raw materials have gotten really expensive. And this is really sad, the remains of a big lathe, but there is nothing we can do anymore to save it. This is pretty awesome though. This is from an old bicycle or moped trailer, and we're going to completely rebuild that trailer in this episode. Scattered all around here are galvanized steel shelves, and I need basically all of them for my storage room. Plus, galvanized steel sheets have also become super expensive. Down here we have an automotive style inverter, and we're going to take a look at that as well. On top of that, we're going to fix this locker here and take care of an old miter saw that a friend has given me. Let's head to the workshop then and get going. Let's take care of this saw then. It was manufactured by the German company Haffner some 50 years ago and was used in a woodworking shop for a long time. Haffner doesn't exist anymore, but we have encountered them before in another episode when we fixed this bench grinder. I carefully start to clean the saw all around while familiarizing myself with its design. It is a combined miter and table saw, probably quite unusual for its day, and it has a slide mechanism not unlike what you find on modern compound miter saws for woodworking. The difference is that it also has a small adjustable table on the top, allowing you to use it as a mobile table saw. Well, when by mobile you mean two strong men being able to carry the saw around if they choose to do so. The wooden handles are not original. They were added by the former owners. The table saw has no guard, no riving knife or any other safety features, but I guess that I will probably not use it as a table saw anyway. The saw has many rusty parts and I will start disassembling it in just a minute. But before I do that, I will try to check various features of the saw by trying to move the various mechanisms. Along the way, I already start to clean some dirty parts though. After taking off the fence, I try to adjust the height of the table, i.e. the depth of the blade. The parts are very rusty. The same goes for almost all hinges and movable parts on this machine. The back part of the slide rails, which were apparently not used very often, are also very rusty, while the front sections are almost like new. These wooden spacers that were added to the fence of the miter saw, probably also by the former owner, are removed because they are damaged. And so is this insert here that the blade has cut into many times. I'm now also removing the dirt and grime off the surfaces of the cast aluminium tables with penetrating oil and some steel wool, which works pretty well. At this point I started to actually disassemble the saw, taking almost all of the rusty parts off. And the first big section that has to go is the height adjustable table. In the next step I detach the belt cover, and underneath we find two really old V-belts. The blade guard assembly also has to go before I manage to unscrew the old rusty saw blade. And now I can also pull off those belts, and you can see in this close-up that they are super brittle indeed. Replacements are ordered right away. And since it's rusty as well, I use a plastic hammer to drive out this massive axle holding the arm of the saw. Underneath the miter saw table we also get to look at the mechanism that allows you to adjust the cutting angle. There also is this 50 microfarads capacitor for the induction motor. It has a date code from 1970. I first thought that I'd probably had to replace it after 52 years, but I measured the capacitance and it reads exactly 50 microfarads. And since there is no visible damage and since the capacitor works as it should, I see no reason to replace it. In the meantime, I have collected all the smaller rusty parts that I have removed from the saw. In order to treat the surfaces, I will once again use citric acid. It comes in the form of white powder and can be dissolved in water, like I did in this bucket here. There is no golden rule how much citric acid to dissolve in the water. It depends on the amount of rust and how much time you have. A more concentrated acid will remove the rust faster, but it will also be more dangerous to handle. Even though in the case of citric acid, some gloves and some glasses should suffice as protection. After the parts have sat in the acid for a few hours, I take them out and rinse them off. After that, I try to dry them as quickly as possible, because otherwise they can start corroding again rather quickly. Whatever rust might still cling on the surface is scrubbed off with steel wool. A thin film of oil can be applied as a mild form of rust prevention as well. Other than the rust, the old saw blade still looks okay, but it also wasn't hard to find a modern replacement for a relatively low price. Some parts like the slide rails are kept in place and the rust is removed by mechanical means like wire wheeling. It is often the better way to not disassemble every part of a given mechanism. In the next step, the saw can be put back together, and the procedure is of course the same we already saw, only in reverse. A new wooden insert is cut out of a piece of wood. Unfortunately, I didn't have a board with exactly the right thickness at hand. In the meantime, the replacement belts had also arrived and were installed. And shortly after, we are ready for a test. Let's have a look at this locker then. I found two of these lockers on the street some time ago when a local building was renovated. They had thrown out a lot of the old furniture and I made sure to save at least some of it. A German-made locker of this type is not cheap, probably 400 bucks and up when bought new, but it has a few issues. It's somewhat dirty inside. Tape and permanent marker have been applied to the doors, giving the locker a used and somewhat undesirable appearance. On top of that, the locking mechanisms of 2 of the 6 doors are incomplete, and we'll have to fix that. Actually, the former owner had already ordered some replacements. I found them in a plastic bag inside, but they don't fit. So I ordered the correct replacement parts, and in the meantime we can take care of the tape and the Sharpie markings. So let's try a few different techniques here. In an earlier episode I mentioned that a steam cleaner is a really handy tool to remove old stickers. But those cleaners are expensive and most people don't own one. A much cheaper solution is a heat gun. You have to heat the stickers or the tape evenly, but pay attention not to overdo it or otherwise you'll damage the paint beneath. Once the tape is heated up, it is usually quite easy to scrape it off. But even if you do it like that, the tape will usually leave behind a gooey mess. And there are various chemicals and cleaning agents that you can use to take care of that. A solvent that works quite well against the adhesive as well as the permanent marker is ethanol. In Germany usually traded under the name Spiritus. That's similar to spirit. It works well against the adhesive, but usually can't erase the Sharpie or adding markings entirely. Let's try it with WD-40 then. The penetrating oil also works really well for removing the tape remains and also removes most of the marker, but unlike the ethanol, the WD-40 will not just evaporate within a few minutes, but leave behind a film, and this is usually undesirable with this type of application. Another substance that you can find in many sticker removers is orange oil, in Germany usually traded under the name Orangenterpen. Especially if you let it soak in, it does a good job in removing stickers and tape. Plus it smells like oranges, which is nice, but in its highly concentrated form it also isn't exactly healthy. When it comes to the mechanical side of things, you also have various options. There is the old-fashioned steel scraper, works well but might damage the paint. Then there are plastic scrapers, some of which also come with exchangeable blades, which is a pretty good idea since they tend to get dull rather quickly. So we have tried different agents, but while all the adhesive is gone, no matter what substance we applied, some markings remain. In that case, we can still try to use more aggressive approaches like gasoline or paint thinner. In this case, I'm using acetone. The acetone will get rid of the permanent marker very effectively, but you have to be careful and swift, or otherwise you will damage the paint. I only use acetone when the other methods shown have not worked well enough. After cleaning everything with cleaning wipes, the surfaces look almost like new. But those locking mechanisms are still missing. The replacement parts have arrived now though, and luckily they do fit. Now when you try to do something seemingly simple like changing a lock, for example, you might think that this kind of stuff must be standardized by now. But let me tell you, no matter what it is we're talking about, there are a million different types and sizes of just about anything, and in this case I simply got lucky that the first replacements I ordered simply fit. But while the locker might look almost like new now, I think that it's still missing something. That's why I designed some new stickers that I'm now applying to the doors. The first sticker has a transparent background. I really like how it turned out. The second door gets an oversized version of my older design. The third door gets another transparent sticker. And for the fourth door, I've chosen this warning sign that I found on the scrap some time ago. What do you think? Do you like the designs I came up with here? Let me know in the comments. Let's rebuild that bicycle trailer then. It is made from aluminum sheets and comes with some historic German racing and Formula 1 stickers from the late 70s and early 80s. From the inside it is super dirty and has lots of old adhesive on the side walls. In one spot we find a rather big dent. Since this is aluminum, there is no rust of course, and I think that the adhesive was used to attach PVC floor covering as protection to the inside of the trailer. And I start by putting the trailer on some wooden beams, and now I try to beat out that dent with a hammer as good as I can. A perfect result is not to be expected here, but I guess I did okay. In the next step, I used the steam cleaner to thoroughly clean the remains of the trailer inside and out. I will keep at least some of the stickers though. They are historic and should be preserved for the future. And now a metal scraper and acetone I used to remove the old hardened glue. In this case acetone is okay because the paint job does not need to be preserved. With that being done, all surfaces are degreased and the old stickers are taped over before a new paint job is applied and left to dry. Okay, so we have the body of a bicycle or moped trailer with some cool stickers on it, but that's really it. In other words, a frame needs to be built. For that purpose I had already ordered some square steel tubes and I started to cut 4 of them to the same length. Here the aforementioned Haffner bench grinder also came in handy. It was repaired in episode 19. This is episode 30 of my Scrapyard Repair-A-Thon, and if you want to watch the older episodes, you can find them down in the video description under the video. In order to fasten a set of wheels to the frame, some steel angle pieces were drilled and cut. And eventually welded to the frame. But of course the trailer also needs to be coupled to a bicycle, so I began to cut and weld the parts for a trailer hitch that would connect to our square frame. But after a short real-life test, I decided that it would be better if the frame would be angled in the front, making it less likely to outright bump into obstacles. The frame was also painted and left to dry for a few days. While I waited for the paint to dry, I started to work on a cover that could be placed on the trailer, like the lid on a pod. It would protect the insides from rain, or combined with a padlock would make it possible to park the trailer somewhere without all your stuff being stolen. For that, I welded another frame from some angle pieces and used one of the galvanized steel shelves we found on the scrap. It was cut and riveted to the frame. Then the steel sheet was bent around the frame by hammering it down. Since the paint needed really long to dry, I got more ideas. It might sound a little gimmicky at first, but I figured it would be a nice idea to add a small solar panel to the trailer. Combined with a charger and a battery, it could turn the trailer into a rechargeable mobile power station. Well, if a small one at that. So I ended up gluing the panel onto the galvanized steel cover. With the paint finally hardened, the trailer could then finally be assembled. So I say we take her for a spin. Okay, so the trailer has a solar panel. We also have a charger and a 12-volt battery. But what we are still missing is an inverter that would turn the 12-volt DC into 230 volts AC. So we could use the setup to actually power mains equipment. Well, as you might remember, we also found an inverter on the scrap. It has some rusty spots and seems to have been exposed to some humidity, so let's open it up and see if it has any kind of water damage inside. These automotive-style inverters are usually installed in an enclosure that consists of an aluminum extrusion which acts as a heatsink for the power transistors inside. In order to see if there's any humidity trapped inside or possibly other damage, I will pull the entire circuit board out of the enclosure. The traces on the bottom side of the PCB have some water stains, I think, but at this point everything is dry and there doesn't seem to be any other visible damage. Now, normally you shouldn't operate the inverter with the MOSFETs disconnected from the heatsink, but if you don't connect any load and turn it on for only a very short time, nothing should happen here. So I'm connecting a 12-volt lead-acid battery and turn the inverter on. And we measure an output voltage of roughly 230 volts AC, just as it should be. It seems that the inverter is working just fine and was thrown away anyway. Okay, so now that we've opened this up, let us identify some of the components and just talk about what they are and what they are doing. Now, first of all, some observations. Well, what are we trying to do here? Just as a reminder. So 12 volts DC are going in, positive and negative, with pretty thick wires. And on the other side, 230 volts AC are coming out with relatively slim wires. Now we can already tell that, of course, the same amount of power ideally would go in that goes out. So at a high voltage you need much lower current. And at a lower voltage you need much higher current to, well, conduct the same amount of power. And what we have here is that 12 volts are being charged onto these capacitors here. They are all connected in parallel. Then we have two very chunky diodes, and the job of those diodes is just to basically create a short circuit when you accidentally use the wrong polarization. In that case then well, ideally both of these fuses here, these automotive style fuses, will just burn through. Now, given that you have connected the battery correctly, so with plus on red and minus on black, you will have 12 volts DC across these capacitors here, and what is then going to happen is that you have 4 high current, low voltage MOSFETs. That's a specific type of power transistor. And these power transistors are going to chop that 12 volt DC into high frequency rectangular pulses that are being fed into these ferrite core transformers here. Now, technically speaking, we have two paralleled push-pull converters. The German word here is Halbbrücken-Gegentaktwandler, which means a half-bridge push-pull converter. So we have two half-bridges and two transformers, and these are two DC to DC converters that are working in conjunction. See, this is a 600 watt inverter. If you would have like a 300 watt converter, they would probably just leave free space here on the PCB and just use one of the converters. So this is just the same structure, well, times two. At the output side, these little ferrite core transformers put out a high frequency AC. High frequency in this case means a couple of kilohertz, maybe 50 kilohertz. So that's 1,000 times faster than the line voltage. But we're not keeping this AC. It's rectified via this full bridge rectifier here. You can see that on these makeshift heat sinks here. And the output of that will be around 325, 350 volts DC, and that is going to be charged on this chunky electrolytic capacitor here. And you can sometimes tell these things by just looking at the ratings. I said that these capacitors here are charged to 12 volts, and you can see that they are rated at a maximum of 25 volts. On the output side, we have 450 volts, with 220 microfarads being the capacitance of this electrolytic capacitor. So let's say we have 325 volts here, which would be the peak voltage that 230 volts AC would reach twice within each cycle. And that is what these other four transistors here on the opposite side are good for. They form one H bridge, one full bridge, and they will simply chop this high voltage DC into high voltage AC at 50 hertz. Now, if you were in America, for example, and this would be an American inverter, it would be exactly the same, just that we would have not 350 or so volts, but maybe half that, and then we would get 110 or 120 volts RMS AC at 60 hertz here on the output. But generally speaking, the layout would be very similar. Now, these sleeves here, these rubber or silicone sleeves here, their job is to insulate the housings of these MOSFETs here from the aluminium enclosure, so that there is no electrical connection, which would essentially short out some of these parts and could also, well, bring the enclosure in contact with dangerously high voltages. Some of the other stuff that you have here are two switch mode power supply controllers. One is controlling the two push-pull converters here that are operated in multi-parallel configuration. Then you have another one, and this one is basically driving the output stage bridge for the 50 hertz AC. We also have this buzzer here, probably connected to an op amp here, and this would be probably some kind of under voltage warning circuit of some kind, or maybe it controls the fan over here. So that's just additional circuitry usually to protect the basic circuits. You could live without that, though. You only need the DC to DC going from 12 volt to a high voltage, and then the bridge chopping that into AC at 50 or 60 hertz. In this episode, we will leave it at that. But in one of the upcoming episodes, we will take a closer look at some inverters and also at the solar panel setup for the trailer. One, of course, would also wonder if it would make more sense to use an e-bike instead of a normal bicycle with this trailer. Well, and as always, I hope you liked this video, and if that is the case, then please give the video a like to let me know that I should keep on making these types of videos in the future. And in case you want to support me in that endeavor more actively, you can also make a donation via PayPal, links down in the video description, or become a supporter on Patreon under patreon.com/tpai. See you soon.